folks. Today's episode is going to be about randomizing your samples, and I mean randomizing by when you set up your experiment. As I'm a plant scientist, I will explain that with plants, but I'm sure that works the same in other environments as well. The thing is, you're trying to work as much as possible to keep all conditions the same, right? So that's your job as a scientist, to make sure that you're only changing one condition or two conditions if you've got two different treatments, but all the rest is supposed to be the same. In reality, it's not. So that's why we are randomizing our samples, because we need to account for that. And that may be something in the field, for example, that the soil type changes slightly from one end of the field to the other end of the field, and there's nothing you can do about that. So if you had, for example, one genotype planted up at one end of the field and one genotype planted up at the other end of the field, you couldn't really say that if genotype B, for example, grows less, that this is because the genotype is poor. It could also be that just that end of the field isn't really favorable for that kind of plant. So that's why you would want to mix them up, so that all genotypes get the same chance, let's say, to have the best soil. That's the easy randomization. You could also say, okay, I'm putting blocks over the field, cut the fields into 4, 5, 6, whatever, how many blocks you want to have or can manage to have, and then randomize your treatments within that block. So you say, I know I have a gradient down that slope, so I'll have my blocks down there, that slope, and in each block I assume that the soil is more or less uniform, but I know that from one block to the other there might be differences. That's in the field sometimes more manageable. And this is not only true for the field, that's obviously the same in controlled environment, even though we're trying to control the environment in that sense. But there will always be plants that are closer to the edge of the table, that are closer to the air conditioning unit, that have a little more light, maybe just because the light bulb in one of the lamps is a bit older than the other one and doesn't shine as bright anymore. So there will always be slight differences, so you want to make sure that you accommodate for that in your randomization. Another thing that you want to think of when measuring plants is the time factor. So it might be that you are measuring over a whole day, and then the daytime makes a difference. Plants do, for example, transpire more in the morning than they do in the afternoon. And you want to make sure that you're not measuring one treatment only in the morning and one treatment only in the afternoon. It's the same effect as you have in the field with the different soil types. And while you're randomizing, there are ways to make it a bit more clever or a bit more manageable. So I thought I'm going to show you how I'm doing the randomization in my experiment, because what I'm doing is measuring plants that are drought stressed versus well-watered plants and two different genotypes over the time course of 7 days, and I'm measuring most of the day because the measurements take a while, so I have to account for the daytime as well. So my setup will try and account for all the different factors that play into that. And here are my plants. I have a setup with the two genotypes, that's the blue and the yellow labels. And you can see that sometimes I put the blue in the front and sometimes I put yellow in the front, and then it's always one yellow pair and one blue pair. I've got 2 rows of plants for each day, and then I randomize the day in terms of which day is at what place in the table, so it's not starting near the door with day 1 and then going all the way down to day 7, but mixing that up as well.
I've organized the plants in 2 rows and will have the right-hand row well watered and the left-hand row drought stressed, just to make life a bit more easy for myself. And I always know which ones to water and which ones not to water. So for me, it's important to always compare a pair of plants that start off with roughly the same size, one watered and one not watered. So I'm sorting all my plants in size. I find matching pairs and sort them in size groups small, medium, large to make sure that every day I have a selection of the whole range of plants. Then I sort them onto the table with the second genotype where I did the same thing. That way I get packs of 4 plants of each genotype. I get 1 well-watered, 1 drought-stressed plant. And that's 1 rep for my experiment. And then I've got 4 of those for every day. So within 1 rep I've got all 4 treatment genotype combinations, and they are measured as closely time-wise as possible. And then the next rep comes and the next rep comes, but that's how I accommodate for the time of the day factor in this. So I'm randomizing where necessary and I'm structuring where possible to make my life easier and avoid mistakes.
Alright, that's me for today. I hope this was helpful and not too confusing with all the different factors that I'm taking into account. If you have any further questions, leave me a message or a comment. I'll try and answer that. I'll be back tomorrow. I hope you are too. And until then, keep smiling.